Students, in this session, let us learn how to design a gearbox, this 8-speed gearbox. So, by considering this problem, let us learn how to design the gearbox. The gearbox is used as per the question. It is used to for the machine tool spindle drive. Here in the question, the output speed required is 8 speed. So the minimum and the maximum speeds are given, this 100 and 2500 RPM. Then the input source of power is the motor with 7.5 kilowatt and runs at 1440 RPM. So we have to design the gearbox with a relay diagram or speed diagram and gearbox layout and the number of teeth on each gears. So let us have the look on this problem. Here, the number of output speed is 8. Then the minimum speed is 100 as per the problem given. Maximum speed is 2500 RPM. Then the input motor speed is 1400 RPM. Now we have to first determine the standard step ratio. The formula, as you know, the n max by n minimum equal to 5 power n minus 1. Here the maximum speed is 2500, minimum speed is 100. So in the 5 we have to find out. Then n is the output record output, that is 8 minus 1. So from this relation we can find the phi is 1.583. So now we have the series vector R10, R20, R40. So now we can look whether the value they have found, the phi values lies in the standard step ratio, but it is not so. So we can mark the trial. So let us try the R20 series. In the R20 series, it has a standard step ratio 1.12. So by trial, by multiplying the 1.12 by 4 times, we can get 1.573. It is almost closer to the record, the step ratio value 1.583. So we can fix the R20. We can make use of the R20 series, but the extra multiplication 3 times. So we could the R20 series in the data book, we can have select the speed 8 output speed by skipping the 3 speeds that is underlined here. So by looking into the data book R20 series, starting with the 100. So the data book, it may be 1 or 10. We can have the multiplication with the 10 or 100 as per the requirement phase. So we can start with the 100. That is the problem. The minimum speed is 100. By skipping the 3 speeds, the next speed is 160. So similarly, we can have all the 8 speeds, but ensure the last speed, that is the maximum speed, is 2500, which is given in the problem. So it is so. If it is so, it is correct. Now let us move on the structural formula for this problem. So in the problem, the speed is 8 output speed. Here the 8 can be have the split up 4 into 2. 4 into 2. Then the 4 within the bracket, that is the input. So for all the gearbox, the input speed is 1. That is the motor is. So the 4 into 1. That is the first stage. In the second stage, we have written the 2. That is 2 output speed. Here within the bracket we have to put the number. Here the first stage 4 1. So 4 multiplied by 1, that is 4. Here you write the 4 here. So similarly, the structure formula can be rewritten as first 4, the 8 is split up into 4 into 2. Then the 4 output speed, by default the motor speed is the 1 input speed, 4 within bracket 1. And second stage 2, here within the bracket you have to write. So we can write the 4 into 1 equal to 4. The 4 can be here written here. So the structural formula for our 8-speed gearbox is 4 within the bracket 1 and 2 within the bracket 4. It is a structure formula. First stage and it is a second stage. Now let's move on the speed diagram or ray diagram. Here the 8 speed is given, it split into 2 stage. So for the 2 stage, you can draw the 3 vertical lines so that we have the 2 stages, first stage and the second stage. Now let us start with the second stage. Now we have found the 8 output speed from the standard series or 20 series. Now we start with the minimum speed 100, 160, then close with the ends the 2500 RPM. Okay. So now the second stage in the formula is 2 within the bracket 4. That is 2 output speed and 4 input speed. And also for the speed diagram, we can also in the 4 denotes the 4 space interval. That is each cell has the 1 space. So for the 4 space interval it also denotes. Okay. So we have to select the 2 output speed. By default, the lowest speed as considered as a 1 output speed, that is A, 100 RPM, 1 output speed. Then one more output speed is to be found by skipping the 4 speed, that is within the bracket is 4. By skipping the 4 speed, 1, 2, 3, 4. Then you denote the letter B, that is 630 RPM. So for the second stage, the output is 100 RPM A and B 630 RPM. Okay. Now consider the input to output. First you have the 1 input speed have to be located. Now the formula is there, but the shortcut is the space is 4, 1, 2, 3, 4. Then you locate in the input side, that is a sign side, C, such that it lies more than half of the space. That is 4 space, half is 2 space, more than half is 3. So 1, 2, 3. Here C. So the C just satisfies the condition. The C is the output for the last stage. Okay. Now you look at the C. Now you join with the CA and CB with the solid line. Again, you consider the first stage. So the one input is motor 1400 RPM. So you denote here. If the motor speed is not given, by default, you consider the maximum speed 2500 as an input motor speed bit. But here the motor speed is given, so 1400 RPM. Now look at then 4 output with a 1 space interval. Now already in the first stage C is there, so consider the first stage, the 4 output already we have marked the C. Again 3 more speeds are denoted with 1 space interval, that is D, E, F. Now we can complete the 4 output speed, or you join with the motor input speed with the solid line. Now you from F, you draw a dashed line parallel to the CB. Again, similarly from E, similarly from D. Again, you draw the E, F with 400 RPM parallel to the line CA. It is also applicable for E from E and D. Now, after drawing all the dash line and solid lines, ensure all the speeds are marked. If it is so, in the right diagram is correct. Now we have completed the speed diagram. Now let us look into the next gearbox. Here the gearbox can be denoted with a rectangle diagram. Then you have the 2 divisions for the 2 stage with a dashed line. Now you draw the motor as the input. Then you couple the input shaft with a coupling. Then the motor input speed is 1400 RPM. Then you first stage, let us consider the first stage 4 bracket 1, 4 output with 1 input. 1 input is the 1400 RPM motor. Then 4 output. For the 4 output, there should be 4 gears. So the common rule is you first you draw the gear, the largest gear, then you right side the smallest gear and the left side medium gears can be mounted. First you draw the largest gear and right side smallest gear and left side you draw the medium gears as per the requirement. Then you also draw the matting gears. For the 4 gears also there should be the output, there should be 4 matting gears. Now you join with the 5 is the largest gear. Now you draw the matting gear 6 as per the diagram. It should be missed. So other 3 gears are drawn in line with the other 3 gears 1, 3, 7, so that the gears can be slided to have the proper mesh. Okay. Now that you draw also the denote also the speed. So that is the smallest gear 7. So the output, it is the smallest speed is available. It is the largest gear, it is the smallest speed is output. But is the from the diagram, the for the input, the F, E, D, C is the first stage 4 output. That is 400, 600, 1000, 1600. So the 4 output speeds should be there, but you draw the 7 is the smallest gear. So you have the smallest, the great reduction 400. Then you gradually for the medium gears, you denote the output speeds 1600 RPM, 1000 and 630. So on the first stage is over and come to the last stage. In the last stage, so here the for the second stage, the input is the 400 RPM. That is 400 RPM. So for the second stage, input is 400 RPM. So the 9 and 8 gears are mounted. The speed is 2 (4). Here 2 output speeds. So there should be 2 gears. For that 2 should be matting. There should be 2 matting gears. So 10 and 12. First you draw the largest gear. Then you right side smallest gear. So the 8 meshes with the 12. So for the output, you already have found A and B are the 2 output speed, 100 and 630. So in the 8 gear, the smallest gear. So it's the smallest, greatest reduction, 100 and 630. So N10 is the 630, N12 is the 100, N2 is the 1600 RPM, N8 is the 400 RPM. Okay. So here the speed diagram, sorry, gearbox. Now we can find the number of teeth. Here, first, you can also check what are the number of gears to be required. So in the 4 into 8, the formula is 2 into 4 plus 2. That is 6 into 12. 12. So 12 gears are there. Now we can have the next section, the how to find out the number of teeth. As per the smallest gear is a 7. So for the smallest gear, let us assume the N7, the gear 7 is as the 20 teeth. Okay. Here the speed is input speed is motor speed N1, N3, N5, N7, 1, 3, 5, 7. Let us assume smallest teeth in Z7 equal to Z20 teeth. So first consider the any pair 7, 8. Here Z7 and 8. So driven. And as you know, the formula speed and the number of teeth. It has the inversion ratio. So the unknown is the Z8. So Z8 is 72 you can find. So consider the next pair. Similarly, you can find all the formula. But here for the next pair, it is assumed that all the gears are made from the same model. So we can have the formula 7, 8 and 5, 6. So the center to center distance is same for all the respective gear mates. So the 7, 8, Z7 plus Z8 and equal to Z5 plus Z6. By using this formula, you can easily find out the other formula. Similarly, you can find all the number of teeth for all the gears for the 2 stages. Okay. Thank you.